Good evening, everyone. My name's Aryan, and I am from L2G5, and our group's project name is Project Asclepius. We worked on a health monitoring system, a remote health monitoring system, and the part I did was controlling the actuators, the environmental control node.
Hi, I'm Russell. For our project, I worked on the display node as well as overall design of the system.
Hey, my name is Atharva, and I worked on integrating the sensors with our system and sending the sensor data to the database.
Everyone, I'm Praveen, and I built the website for our project.
So our motivation for this project was to build a health monitoring system for patients who are infected by contagious diseases such as COVID, common flu. This system was designed in such a way that it will be able to monitor the patient's health and the patient's environment. We have found out that the patient's environment is just as important as the patient's health because it kind of dictates it.
Okay, I'll be talking about the communication protocol. Our system has a distributed network of nodes, primarily Raspberry Pi, that communicate to monitor and respond to health and environmental conditions. These nodes interact through various protocols for each selected for its reliability and suitability to task. First, we have the Firebase real-time database, which operates over Wi-Fi. It's the central hub for all the nodes, and it communicates asynchronously to all the nodes as needed. We also have their connected display node, which is the 7-inch screen, and it's a touchscreen screen too, which controls the room environmental. For example, if we consider the environmental control node, it registers actuators with the Firebase database, checks rules for the device control, and communicates actuator state, all through JSON message structures for clarity and precision. Our display nodes are equally interactive as well. They retrieve patients' data and rules for display on the website and write new rules to the database, allowing for dynamic updates to patient care protocols. Asynchronous communication simplifies our system design, enabling independent operation of nodes, which is crucial for scalability and reliability.
This is our display node. We have a touchscreen display attached to the Raspberry Pi that enables to be able to view the website as well. And this node also stores the local copy of the online database as well as sends emails. So using the GUI, we have the ability to look at the current data with the room temperature, the humidity, and the rest of the sensors. So like light, the body temperature, the blood oxygen, and the heart rate. And then we can also add the automation for the room for the ability to control the environment within the room. So you can have the ability so you can name the rule, and then you can set which actuator to run, like an email, a heater, the lights, and the fans. You can then choose which sensor value you want to compare to. You can set what the direction of the comparison, if you want it less than, greater than, or equal to, and then you can enter the value. So for example, you could set the temperature for the heater with the temperature sensor, and then you could set the action to be on, and then you could set less than, and then if you set the value to less than 20, it would then make the heat would then turn on to heat the room if the temperature sensor is detecting a temperature of less than 20.
So this part of our system is used for sensor data collection, and all these sensors collect the information about the patient and the patient's environment, and we run a script on Python to send all the information from the sensors to the database. Also, we are supposed to have two different Pis, one for the environment sensors and one for the patient's health sensors, but for convenience reason, we are only using one Pi for this demonstration. So let me start off by telling you about these sensors. So this is the ambient light sensor, which is also known as the PH1750. So this sensor basically observes the intensity of light in the room, and this sensor communicates with the Pi using the I2C connection. Now, the other environment sensor we are using is the room temperature and humidity sensor, which is also known as the SHT35. So this sensor provides us with the room temperature of the room of the patient and the humidity levels of the room of the patient. And now let's move on to the patient sensors used to observe the patient's health. So this sensor is the DS18B20 sensor, which is a body temperature sensor. So this sensor is used to observe the patient's body temperature. This sensor uses the one-wire communication to communicate with the PI. And the other sensor we are going to be using to observe the patient's health is it's right here. It's called the MAX30100 sensor, which is used to calculate the patient's blood oxygen levels and the heart rate. So this sensor also uses, like all these sensors except the body temperature sensor uses the I2C communication to communicate with the PI. And that's pretty much overview of all the sensors our device is going to be using.
Okay, so this is the actuator section where we have the actual actuators that responds to the sensors. Here you can see that the Raspberry Pi is connected with the header pin, and these are the connections to the GPIO. We're using relay switches to control the actuators. Here are our actuators. Firstly, the fan. So this is supposed to be the minuscule version of ventilation. Secondly, the red LED is supposed to represent the heater. Minuscule version, of course, because we don't have the budget and everything. And this is supposed to be the light control in the room. So yes, it's all connected in series. It's just a minuscule version of what the light control will be. So how these relays actually work, we connected them to a MOSFET. Like a MOSFET is an electrical component which steps up the voltage from 3 to 12 for the relay to take that volt in, so that the relay can turn on and get the signal to the actuators.
So this is the health monitoring dashboard. As you can see in the website, you can see patient name and room number. It also displays the health and environmental stats. For example, you can see room temperature as 21 degrees Celsius, humidity as 17%, and light intensity as 14.16 lux. And if any rule is violated or unsatisfied, an email notification is sent to this Gmail app.
So here we have the actuators and the sensor node, and it's currently recording the ambient temperature of the room. And so we currently have set up the rules that for the lights, the heater, and the fan, they will all turn on if the room temperature exceeds 26 degrees. So if we go and take what's normally the room temperature and bias it a little bit, you will see in a second, once it updates, that all the relays will then turn on, and the actuator is now on. And then there's also going to have been an email sent to the Gmail account.
Yes, so you can see an email sent saying the warning temperature about 26 degrees was violated. Current value was 28, but the set values was sent 26.
While working on this project, I have learned about various types of sensors and how these various types of sensors can be integrated with the Pi. I've also learned like different types of communication styles these sensors use, such as I2C communication and one-wire communication, and how to send the sensor data to the database. That's also one thing that I've learned from this.
In this project, I learned how to build an actual working website. I used JavaScript, HTML, and CSS to build the website. I also learned how to write rules in database from the website.
So in this project, I learned about how to use the MOSFETs to step up the voltage for the relays, as well as designing a database schema for an internode project and handling the communication between all the different nodes and making sure everything can pass the data it needs to and everything is coordinated.
So in this course, I learned about databases, NoSQL and SQL databases, and how to work with breadboards and how do different distributed systems connect together.
We could expand our project in the future into including either the ability to add more rooms. We could also add more sensors and actuators to better monitor and control patients. And we could also think about adding an offline mode so that an internet connection wouldn't be required to have the project operational, and it would be more redundant.
We can also display the analytics from the data and make it into trending graphs where doctors can do research on what the patients are going through and actually put this into their studies.